This video will demonstrate the use of 3D UTAPWeLS in evaluating the resistivity response in a carbonate thin bed layer example. The following will be demonstrated: loading a LAS data file, plotting log files, using the Earth Model Builder to detect bed boundaries and to populate properties, simulating a resistivity log response, matching a simulated log to a field log using the Earth Model Generated Inverse Log, also known as a blocky log, and measuring the water saturation response before and after. With the well log interpreter open, click on the Load Log File icon. In the Import Logs window, click on the Load LAS File icon. Choose the carbonate thin bed LAS file. Note here that the interval that will be loaded is between 5,000 feet to 5,050 feet. Click on Import. The file is a reproduction of actual well log data. Access to the data file was restricted, and these logs were created, and they represent the nuclear and resistivity logs. To help eliminate resistivity shoulder bed effects at the top and bottom of the curves, the modeling area will be extended to 50 feet above and 50 feet below the area of interest. Therefore, the modeling area will be set to 4,950 feet and the bottom to 5,100 feet. The focus area will be the top at 4,900 feet and the bottom at 5,150 feet. In Track 2, the track editor can be opened by doing a double left click anywhere within the track. The All Bed Boundaries is the default and will be kept. Click on the Add Log icon. The type is the LAS core. The set, the carbonate LAS file, the file that was loaded. And the display is the ECGR curve. The limits will be 0 to 50 and the color green. Add a new track, which can be done by using the pull-down menu at the top of the track editor. Track 3 will be used for the resistivity log. The scale will be logarithmic, set to 3 decades. Add a new log from the LAS file, RT90, and use the red color. Petrophysical boundaries will be added, which can be accomplished by 2 methods. Adding them by hand, as demonstrated here. This at times is the preferred method in which one can limit the number of boundaries added. The other method uses the Earth Model Builder to add the boundaries. The second method will be used for this demonstration. Therefore, the ones added by hand will be deleted using the Delete Boundaries icon. Clicking on the Detect Boundaries icon will open the module within the Earth Model Builder. In this left panel shows all the logs that were loaded. For this example, the ECGR log will be used for the boundary detection. Highlight the log and click on the arrow to add it to the Logs to Detect panel. In the boundary filter window, the sliding window size is set to 0.25, which has been found to find all the boundaries for this example. It would be instructional for you to try different values above and below 1 to see the number of boundaries that are added. If the curve has noise associated with it, the noise threshold could be used to filter out some of it. Add another track to plot water saturation. Click on Add Log. The type will be Earth Model. The property, the total interconnected water saturation. The set, formation zone. Set the limits to 1 to 0 and the color blue. A numeric log may be added to give another perspective. In the Populate Properties module of the Earth Model Builder, an Earth Model Resistivity curve or blocky log will be generated. This inverse generated curve will be used to match the simulated resistivity curve to the RT90 resistivity curve. In the row with the resistivity parallel or homogeneous under Zone 1, use the pull-down menu to add the RT90 curve. Click on Populate Properties. To prevent the resetting of this inverse log to initial values after future adjustments are made, use the pull-down menu to enter Select or click the Reset Master Curves. In Track 3, open up the track editor. Click on the Add a Log icon. The type will be Earth Model. The property resistivity, the zone formation, and increase the width to 1.5 to see the curve better. To calculate the water saturation, use the petrophysical calculator within the Earth Model Builder. It may be accessed directly using this petrophysical calculator icon. Only the water saturation needs to be calculated. Therefore, the bulk nuclear properties will be unchecked. Check Archies and Similar and change the calculation type to water saturation from resistivities. Click on Calculate. The log in Track 4 should now reflect water saturation values. The simulated log needs to be calculated. Click on the resistivity logging simulation icon, Omega. Choose the AIT tool. Simulation variant will be 2D Schlumberger. The AIT tool option will be AITH. Click Simulate. A terminal opens and the simulation is run. Open the track editor for Track 3. Click on the Add Log icon. The type will be Simulated Log. Set will be AIT, and the curve will be RT90. We'll set the style to dashed and the color red. Note that the simulated log, for the most part, is separated from the field data log. The inverse Earth Model Resistivity curve, or blocky log, will be used to match the simulated log to the field data log. Move the blocky log in the direction that is needed to match the simulated log to the field log. Adjustment of the bed boundaries may also be necessary. Use the up-down arrow icon and place the double arrow over the boundary to be moved and in the direction needed. This adjustment process has been sped up to present the result of the simulated log matching the field log. Once the best fit is accomplished, use the petrophysical calculator again to recalculate the water saturation. Be sure water saturation from resistivity is chosen. Note the changes in the water saturation values. This is the end of the video. Thank you for your time.